to start. Share screen. Should be this one. Yes. So, oh no, got to the wrong one. Hold on, okay. Should be this one. Can everyone see my screen?
Yeah, I can.
It's the NumPy, is it? Is it the same thing on your end?
Yes, ma'am.
Oh, okay, thank you. Okay, so we will, we just have a little bit left over for NumPy, and this concept is also quite useful. Okay, so let's just do a quick discussion. So this method, this function in for NumPy array, okay, argmax. And over here, let's first take a look this time. This is a NumPy array. And if you recall, we can also use the line space to generate a sequence of number. And so here we have this sequence of number. And then what is this data? This data is also a NumPy array. Is it the shape? And if you recall, we learned the reshape function. So it's a 5x4 array. And so this is the 5x4 array. And then if you take a look next, so for this 5x4 array, so this NumPy array, and we call the dart argmax, so argument maxima kind of, the argmax. And also we specify the axis. Okay, so axis here is 0. 0 is the first dimension. The first dimension is row, is it? So what it does is we'll find, so 1 by 1 for each row, so along column, but compare all the items from each row. So which one is the largest? And clearly we can see this one is the largest. Is it? So this one should be sub 0, sub 1, sub 2. Is it? So this one is 2. And then for the next column, is it which one is a maxima and it's supposed to be this one? So it should be 0, is it? And for the next one, the largest should be this one. So this should be sub 3. And then the last column, the largest one is the second one. So it should be, so it should be this one. It should be, is this the largest? Yeah, this is the largest. So anyway, so this is, so here is the result, is we do have 2, and then 0, 0, and then 3, and then 1. So that's what we get the result. So it gives you index, okay, of the largest item for your specified axis. And if you change it to 1, then it's going to compare along the row, but compare items from column. Okay, so let's be careful about this axis specification. And we know the result. And then here, this is a integer NumPy array, is it? So then we do indexing, is it? So this is a NumPy array. Then you use another NumPy integer array to do indexing. Previously we learned this. So then you can get the item from this one-dimensional NumPy array. So this is regarding the argmax, how do we use it? And we can also to find the shape for specific dimension. So this is for the second dimension, is that the shape is we have 4, is that for the first dimension, then we have 5, is it? So you can also call you can also access the shape attributes. And then how do you retrieve the largest item out? That that's the largest, yeah. How do we retrieve them out? Once we have their location, is it? So we can, if you recall last class, we learned indexing, is it? Because this data itself is two-dimensional. So this tells you the first dimension indexing, because it's an array, integer array, it's not the colon, is it? And then you have comma. So after comma, you have second dimension. So this is regarding second dimension, then indexing. Then it locate the specific item. Okay, by this row, by this column, is it by this row, by this, then you can find you can get the maximum item out. So here it shows us use argmax to get maximum item out. And then you can also do this, like over here is that the max function, okay? You can also call the max function on the array, and then you specify along which axis. So here it's try to find along the row, is it the largest item? And then you can compare if these two results is the same. And it it's the same. Okay, it's true. Okay, that's regarding find the largest item. And what next? Previously, if you recall last class for NumPy array, and we learned the fancy indexing concept, is it? And also regular indexing and slicing, is it? And here for indexing, you can also do Boolean array. Okay, so let's take a look. So anyway, so here we random generate some integers, or not random, this is certain range of numbers between 0 to 11. And then we reshape it to 3 by 4. So it's a 2D array. So here we have this array, is it? And then you want to find, okay, within this array of the items that greater than 4. So we do this. So this is also, if you recall, for NumPy array, it has operations element-wise and a broadcasting rule. So basically, this applies to every item within this NumPy array, etc. So this is also one of the very important features for NumPy. So just keep this in mind. And if you take a look at this result, so it's true, false, but it's what? It's also an array. So we call this a Boolean array, okay? And with Boolean array, then if you take a look, A is this array, that's A. And the B is this Boolean array. And you can also have Boolean array, put it for a NumPy array. Then what this means, you just want to get out of the item that is true, okay? So this just shows us a Boolean array. Quite useful, is it? And you can even use it to do the reassignment, is that? So here is just do the reassignment. So if it's true, then you assign it to 0. So it's quite helpful. And so that's all the general idea about NumPy array. Okay, there are a lot of other stuff, but we think this should do good for most of our machine learning study. Okay, and in our machine learning, if we need more, we can come back to visit the concept if we haven't discussed. And today we will move to another very important new package with when you do machine learning, you also use it quite often. It's Pandas. Okay, so so majority of this Jupyter Notebook is from official Pandas Quick Start website. Okay, and I add a little bit of more. Okay, and for Pandas, okay, for Pandas in NumPy array, it deals with a homogeneous data type. So they must be the same, okay. But for Pandas, it's very flexible. It's a heterogeneous data type. Okay, we will see. And also in Pandas, there are two kinds of major data structure or container we discuss. It's a series, and this is for one dimension, and the other we call it a data frame, and it's two-dimensional. Okay, so let's see. First is regarding series. Okay, series. So of course, if you want to use Pandas, you need to import its package. And in all of like the applications, or professional work, you will see normally we abbreviate as PD, just like NP for NumPy. Okay, and here we also import NumPy. Okay, and if you take a close look over here, what is this? This is a list, Python list, because we have the square brackets, is it? But over here we have NumPy, the null value from NumPy, okay? And you can call Pandas series function to create, and you plug in with a list, okay, passing in a list. Then we can create a Pandas series. So Pandas series is what? Is a one-dimensional array, but it's different with NumPy arrays. It has labels. Later on, we will see this very helpful. Okay, the axis has labels. So that's different from NumPy array. NumPy array doesn't have label, okay? Pandas support label, okay? So it has labels. So if we take a look, so what does that mean? Okay, so this is that S is the series. If you take a look at the output, it's different from NumPy array. The NumPy array, the output is something looks like this, and comma. That's NumPy array and the array. And this is series. Series. For series, that's what the value, data value. And then what is this part? So this part is label. Here is the axis label. Okay, generally we just say label. Okay, so that's called label. And this is a default one. Default label is 0, 1, 2. So kind of like the index. Okay, that's the default one if you don't specify. Okay, later on we will see there are some other very cool things with Pandas. And then next, let's see. Because series support labels, so when you access a series item, there are two approaches you can try to retrieve items. One is we call with position. With position, this is just like whenever you use array, we do the sub, we call sub I, etc. And or we can call indexing kind of like in NumPy array, etc. So, but we don't see indexing here, okay? We call it with position. With position, it's 0, 1, 2, the implicit position, okay? And it also allows you to access using label. Okay, so that's how we see label is also quite, you can also use label to access. And this is going to be very helpful because a lot of time you may not know where the position is, but you may know the label name. Is it? Then that comes into very handy, okay, if we can access with a label. So basically, this also kind of like if you record dictionary, as a dictionary has key value pair. We can kind of view series like a key value pair, as a key is a label and the value is a data. So that's kind of, we can think of it like that. Okay, so next, let's see. So here, this data is what? This is a NumPy array. Okay, NumPy array. And then we call Pandas series to, we want to create a series. And you plug in. So series also take what? Take a NumPy array. Previous example shows you can plug in with list. It also take a NumPy array. But you see the second parameter. So for this argument, this index parameter argument, so this serves as a label. So we can also call it named label. Is it named index? Is it? And that's how you label the index. You use A, B, C, D, E. Is it? Okay, and because, so what it will look like is look like A, B, C, D, E, F. So that's the label part for this series. And that has 1, 2, 3, 4, 1, 2, 3, 5, 5, 6, 7. That's how it looks like. So this time it replaces the default 0, 1, 2, 3, 4, 5, those integer label with the label that you provided, the named index. And because you provide label index, then you can use it to access, you can specify, is it? So you can use this B, is it? That's the index label. Then you can read the corresponding item, so 2, okay? So that's how we can use label. Okay, that's the first concept in Pandas we learned. It's about series. And the second one we just mentioned for Pandas data structure is called data frame. Okay, data frame is 2-dimensional. Okay, 2-dimensional. It's a heterogeneous. Basically, it's tabular data. Okay, and tabular data, the axis, both the rows and the columns, they have labeled. Okay, they have labeled. And it says arithmetic operation also align on both the row and the column. Okay, and we can also think of it like we predict dictionary like container, as in for series. Okay, but for the data frame, it's multiple series, not a single one. Okay, and we will also see for our machine learning, and then basically for data analytics, most of the time we deal with the data CSV file, okay, comma separated value, okay. So data CSV file. Data CSV file, you can also directly open it in Excel, and it's a plain text file, okay, plain text, but it's separated with comma. And before we move to, let me show you a little bit about CSV file, okay? So here is that CSV file that we are going to use. It's an MBA file, so it has, and if you can clearly see it, so here I open it in Excel, okay? So because for Excel, you have column name. So all these are column name. Those are column name in Excel, and then you have the corresponding, in Excel, we call it a record. And we can see this is totally around over 400 records. So it's a quite a big file, of course not too big, is it? Okay, so anyway, so this is a general idea about Excel. In Excel, you can view a CSV file. And next, let's see, we can also view it in plain text. Then you may have better understanding. And here, if you take if we take a close look, I open this .csv file just in a plain text editor, notepad. Is it? If you say it's kind of messy, but if you take a close look, you will find the very first line for this plain text file is Excel tables column name. And then if you take a close look of each record, you will find it has a comma. Is it all has comma? So that's why we call it CSV, comma separated. So comma separated all of the values for, and each line is one record. Each line is one record. Is it? So it's built quite nicely. Is it? Very structured, even though it's a plain text. Okay. And then next, let's take a look at so now let's take a look. How do we deal with the CSV file? Is it? So Pandas is very powerful to deal with the CSV file. So you just call, it has a method called read underscore CSV, and then you specify the CSV file. Okay, and of course, over here, I have it in the same folder as my Jupyter notebook, so I don't need to specify path. Okay, and so after you call this read CSV, what it returns? It returns a data frame. Returns a Pandas data frame. Okay, so this DF is a data frame. And because the data frame, then it's a quite large one, a lot of records. It's over 400. Over 400, is it? So if you want to see all of them, it's going to take a lot of space. So over here, you just want to get a glimpse a lot of times at what the CSV file look like. Then you can call the data head function. So then here it shows you, it's, if you take closer, it's quite similar as the Excel sheet, is it? So you have column name, and by default, this is the default raw index label. This is the label. Okay, and basically this is column label. So data frame also support named label. Okay, named label. Here we didn't specify to use a default. Okay. So this is how you open a CSV file, okay, and then take a glimpse of the CSV file. And if you take a look, then you can get the specific column out here. So this is DF is a data frame. Then you specify the column name, column label, etc. So basically the name. And this is what? This we will get a series. Is that you can then also assign it to a series. And then what we have. So for both data frame and series, if you call the head, you can also specify how many records, the top 10 or the top 5 or the top 9 record you want to see. So you can also plug in a number. So here says, okay, I want to take a look at the top 10 records for this series. Basically, it's the top 10 MBA names on that CSV file. That then it will give you all the result. Okay. So that's regarding the head. And we can also do this. So here we call data, is it? So this is data frame, Pandas data frame, is it? And then we have square bracket, and within it we have colon. So then from what we previously learned, is it, this is called slicing. So slicing still works for series and data frame, okay, for pandas. And here then, let's see, the data. So data is, oh, I'm sorry, I need to. This is our data, is it? So this is the data, it's a series. It's a series. So it wants to get 3, 6. Is it 3, 6? So here 3, 6 is what? It means this named label, but this goes with the default one. Okay, default one. So we can see, is it? So it will retrieve 3, 4, 5. Okay. So anyway, so this slicing, okay, you can use the label to do slicing. And in pandas, there are other ways. It's not just limited with the square brackets, okay. We can also do call the dot lock function. So location. And after you use brackets, okay, within brackets, you can do indexing or slicing. Okay, so let's take a look. So here, be careful, okay, this S is a series. This series, that's all of the data, it's net. And it's index. So here is a label index. Label index. The index, the first one is not 0, it's 49. Second one, 48, then goes 1, 2, 3. Is it? Then you do dot location, is it? You call dot lock. So this 2, 3 doesn't mean the default position. This is the named label index. So it's all the way to what? To this one. Okay, this one. And also be careful, it's inclusive. It's inclusive, it's included. Okay, when you call dot lock. So be careful, okay? Some subtle difference here. Okay, and if you take, you can also call dot lock 3 to 6. So it did get 3 and 6, the label and including, okay. So this is dot lock. And pandas also give you another option. You can also call dot I lock. So integer location. is it kind of? So I log. Okay, so that's going to always use position. Okay, position. And over here we do slicing. Is it slicing? So the first three, 0, 1, 2, 0, 1, 2. So this is 3, then it's not included. Okay, so be careful, there's subtle difference. And the same thing when you can also do I log. You can specify. Okay, so then that is the position. Okay, when we do I log, it's using position. And what next one try to show is we can also change type. Okay, conversion operation. Okay, for Pandas series. And over here we have that NBA file again, is it? And you can also drop null values. Okay, so drop null values is called drop NA. Okay, when we do machine learning, we will see we need to also do some certain level of data cleaning. Okay, so it's a drop NA. Okay, and in place it's on the original data. So drop all null value columns. Okay, so that's what this part means. And then if you want to know the data type, you can call the data D type attribute. Okay, and what next one try to show, okay, for this salary column, number column, for those column, I'm going to change the data type. So if you want to change the data, you can call S type. Okay, then you specify what the data type is. So integer or string or something else. And then you can double check the data type, is it? And here it does shows us, is it? And we care about salary, is it? Salary, then we change it to integer, it does get changed. Okay, so this is shows us you can also change that type. And in Pandas, we can also use the date time index. Okay, date time index. And the Pandas also has a method called date underscore range method. And then if you plug in, this is 2013, January 1st. So give you the date, because in Pandas Pandas a lot of times to want to deal with time series. Okay, so it take care of time series. It provides a lot of useful function related with date and time for us automatically. And then if you specify the period, is it okay? So it means 6 days. Is it from January 1st to January the 6th? Okay, so this is dates, all of the dates. Is it? And then here it says I'm going to create a data frame. You can also create data frame. Previously, the data frame, we got it from read the CSV file that automatically return us with a data frame. Here you can also create a data frame yourself with some random number we already learned. So for index, okay, we are going to use data time. And for column, if you take a look, is it also provide a name. And when you provide name, you can also do some list. Is it? Okay, this list give you, so it's A, B, C, D. So you can specify the index and the column arguments, okay, parameter. So this is a data frame. And to create a data frame, there are multiple ways. You can also pass dictionary to create a data frame. So here it says, okay, A, B, C, D, is it? And then all of this will serve as column. And then following that, it's a sequence of items. Is a sequence. For A, it's 1. And for B, it's timestamp. Is it timestamp? And then for C, it's some series with 1, and the index is what, and the data type is it. And then for D, so here you can also see the different type. It's a different type. And for this one, it's a categorical data, okay? And for machine learning, we will also see, and we sometimes need to do some conversion, okay? But anyway, Pandas also support categorical data. Is it like good, very good, best? So that's categorical data, okay? And then for this data frame, then it's generated with the default row index and with the named column index. Okay. So just shows another approach. And the data frame, we already see this, the data head. And you can also see the last number of records in a data frame. Then you call tail. Then you can specify, you can also specify the number. Okay. So that's the data frame. There are multiple ways. CSV file you can create from scratch, okay, using dictionary or using some array. And if you want to know of the name of the index, you can call data index. Is it? And for our data frame, then in this case, they said, okay, it's daytime. Is it? And the column, it also gave you the name. Is it? And if you want to get a value, then you just call data value. Is it data value? And when we do machine learning, we only need a value, okay, not the index and the columns. And Pandas also give you a very nice function called describe. Give you some statistic summary of the data. Okay, so like over here for that data frame. And this is the summary, kind of like summary report regarding the data. Is it? You see, this is how many records you have. We have 6. Is it? For each column, we have 6. And the mean value for each column, standard deviation, minimum value, 25 quantile, 50 quantile, 75, and the maximum number. Is it? So you kind of, from this describe, you kind of get a glimpse of how the data's distribution. Is it? Sometimes also quite helpful, is it? Okay, so that's regarding the summary for the data. You can also transpose. Okay, previously, if you recall, the date time index is for row. So this convert from row to column. Okay, you can also do that. Is it? So then you can call the transpose. And we can also do sorting, okay, for the data frame data. And we can sort by a specified axis, okay. So let's take a quick look at this one. So this is a general data frame information, is it? And then what you do is you call sort underscore index. Be careful, okay? This means you sort index itself, not the data, not the value, okay? It's index. Then you specify the axis. So here axis is second dimension. So it's regarding the column, okay, regarding column. So you're going to do descending, is it ascending force? So that's descending. And then let's see the result. If you take a look, yes, then it's rearranged. Is it previously it's A, B, C, D. Now it's converted to D, C, B, A. Is it? Because we sort index. Okay, the second dimension. And you can also specify the row, okay? But be careful, okay, with the row. Because over here it's, oh, this is just sort index. Yeah, so that's fine. We don't need to worry about this. And then next, when we do sort value, okay, we need to, sometimes we need to be careful. And if you do want to sort value, is it a sort value, then you can also specify by which column, is it by which, so you can plug in with by equal and then specify the column name. Okay, so this is how sorted by this column. So only this column is sorted. Okay, the other column values are not sorted. And you can clearly see the result is January 1st, then January 6th. So it is sorted. And over here, I say, oh, you can also call sort value. And here specify by which row. Is it axis is 1? Is it? But be careful here, okay? And this case works because the data is homogeneous. When you have heterogeneous, when you do sort, that doesn't make sense. Is it? You cannot compare apple with orange. So when we do comparison, then we need to compare the same data type. Okay. Okay, so that's regarding sort index and sort value. Okay, in Pandas. And what next one is previously we already discussed data log and data ilog. Okay, and next we will see you can also call data at and data I at. Okay, data ilog we already see is it use position. Use position. So here it's going to do what? So it's within the log, you plug in kind of like an array, etc. So in the integer array, so it's what? It's do indexing. Is it indexing for the first dimension? Is it? So the row. So I only get this two. And you can also do ilog. Is it ilog for both dimension? Is it? And then in this case, first dimension is do slicing. Slicing. In this case, slicing didn't specify. That means all rows. Is it? And for column, we do what? We do indexing. We do indexing. That's why you only pick column A and column B, okay? But for the row, if we take a look, we take all of the rows, okay? So this is ilog, so use the position, okay, using position. And then next, let's see. You can also do some df, is it? Don't call data log or data ilog. Then you plug in. This is kind of like NumPy. In NumPy, we do that, but NumPy doesn't have named. And here it has named. It has named the index. So for the df, in this case, then we do column A and the column B. You can also just directly do the df with this. Okay. But here, be careful, okay? If you take a look, I commented this out. So over here, over here is oh, for the first dimension, I do 0, 5. 0, 5 is position. Positional indexing. Is it? And over here, you do label name label slicing. And we didn't call the dot lock or I lock. Is it because anyway, this is for position, this is for name. And you can, if you just go ahead, you say, I'm trying to just do square brackets to do positions indexing, you cannot do this. Okay, you cannot do this. So you either need to choose dot lock or you choose dot I lock and specify either using position or using named label. You cannot mix both together. Okay, so that's what here try to show. Okay, but if you want to select a certain range, then you can call dot lock. Then you specify this is for row, this is for column. It's separated by comma. Okay. So, and for DF, if you also do this using position, it's not supported. So you better use I lock. Okay. So for C, if we do this or do I lock, that's always going to work. When you just do DF, you need to be careful. Okay. So that's lock and I lock, but it does allow you to do this, to do slicing, okay, for the rows. That's allowed, okay. So it's very tricky. We just need to be careful, okay. And here again with that NBA file that we have the first row, and then you see with that data you can call the dot locate. Is it to locate a certain row? Is it called the dot lock? Oh, and also here with this CSV file, this time we said what? You also gave your column. So this parameter is we can have named column. Named column. So these are all the name of specific column. And over here you say, I give name. Is it? I gave the name. So what this name, initially, if you recall, it's from that CSV file. It has that name as column. As column. And here, what this going to mean is you're going to put this as row label index. Okay, so you pick that specific column, okay, specific name column, and then it's going to serve as index, as a row index. And because it serves as a row index here, that's why when I do the dot lock, I just specify the name. Is it? I just specify the name. This name is a row name. Is a row name. This is the row name. Then you can get all of the corresponding information. Is it? And you can clearly see this is quite efficient and helpful. Is it? And what next tries to show, okay, we have this data frame. Previously, we already see, is it A, B, C, D, and the row name is dates, is it? Then you can also, because the dates, okay, you can also specify specific item, is it? So that's allowed. So we get the specific item. And then you can call the dot lock, is it, to locate the first record. Okay, first record. Okay, and so today, let's just stop here.